Hello friends, so in today's question, block A weighs 4 Newton and block B weighs 8 Newton. The coefficient of kinetic friction is 0.25 for all the surfaces. Find the force F to slide B at a constant speed when, for A, this is figure A for part A is held at rest with the help of the string, and this is figure for B, part B rather. A and B are connected by light cord passing over a smooth pulley as in figure B. So in this case, let us first of all discuss part A. And the important thing is here that B should be sliding at a constant speed. Okay. So for the constant speed, the net applied force in this case will be F, and the opposing force, which will be the frictional force, should be equal. So that's the basic concept that can be applied both in figure A as well as figure B. Okay. So first of all, let us draw the free body diagram for case A. So this is our block A and this is our block B. Block A is connected with a string and we are applying a force F on the block B. Now this block B will try to move towards left side, and because of friction between A and B, it will also try to force A to move towards the left side. Let us call that with force Fr1. So there will be equal and opposite Fr1 that will be acting on B because of A, and as this surface is also having some friction, so there will be also opposing force Fr2 which will be acting on block B. Okay. And there will be, the weight is given as 4 Newton. Okay, so it means there will be 4 Newton for A acting in downward direction, and there will be normal N1 which will equal to 4 Newton, and for B there will be 8 Newton acting in downward direction, and there will be a normal N2 which will be 8 Newton in the upward direction. So these are the various forces which will be acting on blocks. Okay, so we can find out what will be our Fr1. Okay, so we can say that Fr1 will be equal to mu into N1, and mu is given as 0.25 and that is 4. Okay. And similarly we can find out Fr2. Fr2 is mu N2 and mu is again 0.25 and our N2 is 8. Oh, sorry, my mistake. Fr2, let me draw it here. This is my B and this is A. So this is our Fr2. Okay, so the combined normal, the combined weight of both will be acting in downward direction. That will be 8 plus 4, and therefore let this be now N2. Let us move here, and that will be equal to 12. Sorry, mistake. So we can write this as 0.25 into 12. Okay. Now for the block B to move at a constant speed, so you can say for block B to move at a constant speed, the applied force F should be equal to Fr1 plus Fr2. So we already know value of Fr1. Fr1 is 0.25 into 4 plus 0.25 into 12. So we can take 0.25 as common. So this will be 4 plus 12, and which will be equal to 0.25 into 16. Okay. So we can say that F will be coming as, solve it, 25 divided by 100 to 60. Okay. So this will be 4 and this will be 4. So applied force F should be equal to 4 Newton. This will be for A. And for B, now for B part, in this case both A and B are connected using a string. So this is our A and this is B, and they are both connected using a string. Like this. In this case, the force is being applied on B. Now once again, we can draw the free body diagram for both A and B and try to find out various forces which will be acting on it. So block B, let me draw it here. So this will be A and this will be B. So we have a force F which will try to move B towards left side, and it will be also trying to, you can say, force A also to move towards the left side. Let us suppose this is because of the friction, so let us call this Fr1. So we have the equal and opposite Fr1 here, and the B is also moving on the path which is having some friction, so it will be Fr2, and both are connected by string, so this will be T and this will be also T. And for A, it is given that there is a 4 Newton in the downward direction, so there will be N1 which is equal to 4 Newton. Okay. And in case of B, the normal on B will be dependent on both. This is our A is given as 4 and this is 8. So total will be coming here as 12. And the normal, let us call this N2, this will be given as 12. So we can say that for, let me write it here, the force F will try to move block B towards left. Okay. Therefore, you can say, therefore, block B will also try to move block A towards left with the force which will be nothing but the frictional force. Okay, the force which we can call that as a frictional force Fr1. Okay, it will try to move. It will try. Okay, actually it moves or not is a different story, but it will try to move A towards left with the force Fr1. Next, therefore equal and opposite Fr1 will be acting on block B. Okay, therefore equal and opposite force Fr1 will act on block B, okay, towards the right. And the last is a frictional force Fr2 will be also acting on block B. Frictional force Fr2 will also act on block B towards right. Okay, towards right. So these are all the forces along with tension. Okay, or we can also say tension T will also act on A and B towards right side. Now here the important thing to remember is that the tension will only come into the picture once, or we can say after, the frictional force. Okay. It means as the block starts to move, then only tension will come to the picture, otherwise tension will not come to the picture. So we can, based on the free body diagram, we can write the equation. Okay. We can say that for block A, we have tension will be equal to Fr1, tension will be equal to Fr1, and Fr1 is nothing but our mu n1, okay, and mu is given as 0.25 and n1 is our 4. And for block B, we have applied force F will be equal to Fr1 plus Fr2 plus tension T. and you can write this as FR1 will be equal to 0.25 let me solve it the other way. FR1 is equal to T. Okay, so if we in T we can substitute our FR1, so we get this as FR1 plus FR2 plus FR1, which is equal to 2 FR1 plus FR2. And FR1 we already know is given as twice is our 0.25 into 4 plus FR2 is our 0.25, weight is our 12 or FR2. This is FR2. And we can solve this. Okay. And we can say this will be coming as 2 into 25 divided by 100 into 4 plus 25 divided by 100 into 12. Basically by 4 cancels out. Okay, and this comes as 5 और ये आ जाएगा आपके पास 20, 5 4s are, 4 3s are. So this will be coming as 2 plus 3. So the applied force F will be equal to 5 Newton. Okay. So this is the final solution, that our applied force will be coming in the part B will be equal to as 5 Newton. Thank you.